Hello students, welcome back to JCE Connect series of lectures. In previous lecture we had design of simple slab base plate for the column. So for the given design problem we have been designed and various steps you have seen, and we were designing the depth of pedestal required, and also we have provided the size of the pedestal required, that is the concrete based design, that is the concrete based design. The working load we have considered, working load, then the self weight of the footing considered as 10% of the column load, that is 100 kN, and then the total load acting on the concrete, that is 1000 plus 100. 1000 is the load coming on the column plus self weight of the footing is been taken, that is 1100. Then the area of concrete base required is total load divided by SBC of soil. This SBC of soil is given in a problem, that is 150 kN per meter square, and this is the 1100 kN is the total load acting on the column including the self weight of the footing. Then we get the area required is 7.33 meter square. Then assuming the square base to be provided, then the square base L equal to B equal to root of 7.33, we get the 2.7 meter. Hence provide a concrete base size of 2.7 meter by 2.7 meter. And up to here we have solved in previous lecture. So now we have a base, that is L into B, 2.7 meter by 2.7 meter. This is the concrete pedestal. This one is a concrete pedestal. This is the concrete pedestal. Over the concrete pedestal, this is the base plate of size 0.45 by 0.35. On that base plate, the column is, that is the I section is provided, and for this I section the weld is been done. This is welding. Weld is been done, and length and breadth also we have calculated for the pedestal. Only we think we need to calculate what is the depth of pedestal required. So for the depth calculation we need to assume the load dispersion, assuming the load is dispersing the load is dispersing at an angle of 45 degree. So here this is the base plate and this is the load acting. This is the load acting on the base plate, and after load coming on the base plate, that load is being dispersing through a base plate into the concrete pedestal at an angle of 45 degree. This is the load is dispersing on both sides at an angle of 45 degree. If this is a 45 degree and this total length is 2.7, so 2.7 minus 0.35, what we get? 2.7 minus 0.35, we get 2.35 meter remaining, but this should be distributed on both the side. Then this you divide it by 2, 1.17, we get 1.175. so this side offset 1.175 and this side 1.175 we get. Okay, so this is much we get, and this is the load dispersion at an angle of 45 degree, and this is the depth of foundation. Now we can write tan 45 equal to tan 45. This is, if we take tan 45 opposite by adjacent, opposite is D, adjacent is 1.175. this one, if this we consider it as a 90 degree, tan 45 is opposite by adjacent. From this what we get? D equal to tan 45 into 1.175. so tan 45 is 1, this is 1.175. Then finally the depth we required 1.175 meter. This much up. Therefore, provide a concrete base of 2.7 meter by 2.7 meter by 1.175 meter. This much the concrete base is required. And base plate, on concrete base you have to provide a base plate of size 450 mm by 350 mm by 14 mm. This was the size. Okay, same way provided here. Okay, I hope you understood this problem. So practice this type of a problem, and this problem will be generally asked for 20 marks or sometimes 15 marks. Generally this type of problem will be asked for 15 to 20 marks problem. These problems are 15 to 20 marks problems. Okay, design of simple slab based plate. So just you have to follow the steps given earlier. So these 7 steps you need to follow. So first you need to calculate the bearing strength for the given load, then area required for the slab base. Then after area calculation, just you select suitable size of the base plate, then take the properties of the given section from the steel table. Then after calculating the suitable size of the base plate, just to calculate what is the actual bearing pressure is acting by taking the actual area. Then you calculate what is the thickness required by using this formula. It is given in IS 800 2007. Then do the design connection design, that is just to provide the 4 number of anchor bolts of 20 mm bolts, or you can take a 24 mm depending on the load coming on the column. Then the check the weld length required the column to be welded to the base plate, and how much length of the weld is required, just calculate. Then determine the size of the concrete pedestal if SBCF soil is given. If SBCF soil is not given, so just to assume the SBCF soil and then calculate the concrete pedestal. So these are the design steps for simple slab based plate. Okay, I hope you understood this one. Thank you.